Hello, good morning. Today's lesson is on 6.3, the graphs of a sine and a cosine functions. I'm sure that all of you have done this in your grade 11 U course. And at that point, we are graphing the sine functions and the cosine functions in terms of in degree. But for this particular sections, I want to show you how like everything now is being turned into radian measures. So let's do a quick review on the parents functions of the sine and the cosine graph. The parents functions of the sine graph is y equal to sine theta, okay, or sine x. The variable or the angle that comes after the sine or the cosine, that indicate this is the angle, okay? And so when you are getting like a sine of a 90 degree or a sine of a 180 degree, or cosine of 270 or the cosine of 360. So just don't forget that anything that we put after the letter sine or after the letter cosine, that means the angle, okay? And then, of course, what the sine of that angle is always going to give you the ratio. So the y here, or the f of x, okay, on the other side, really it represents the ratio of the two sine length, okay, the ratio of the two sine length. So let's get started from looking into the table values first before I start to show you the shapes of the sine graph or the cosine graph. So if theta represents the angle, and I'm going to put some key angles here on the table values for the x or for the theta. And then we're going to determine the y values if we're taking the sine of that angle, okay? So let's start from the 0 degree and the 90 degree, pi over 2, and the 180, the pi, or the 3 pi over 2, which is a 270, and the 2 pi, which is a 360, okay? Just a quick review that we all know that every sine or every cosine has a period of 360, okay? We'll go into further of the review of how to determine the periods of each of the cycle. But we all know that in any cycle, any full cycle of the sine and the cosine, it always takes 4 equal parts. And that 4 equal parts for the parents is every 90 degree. Okay, every 90 degree, because if you take 90 times 4, then you will get into a 360. Okay, but when it comes to the graphs of the sine and the cosines for this units, on your graph, everything has to be labeled on the x-axis. The degree is no longer there. So everything has to be in radian exact form. Okay, we don't even use the radian approximate form either. Okay, so be sure that this is what you have to learn in this particular unit of how to do a graph of the sine of the cosine with transformations later on, that on your graph, everything has to be labeled the key points with the radian measures only. Okay, so I'm going to show you a very unique technique to do that. Now, along the y-axis, and the y-axis is just the length of the amplitude. Okay, so it's either it go by 1 unit, 2 units, and so on and so forth, or -1, -2. But it just the along the x-axis that you might find is a little bit different from what we did before, because now everything is not in degree. Everything is in the radian measures. Okay? Now, from the previous sections, we should know that when you're taking the sine of a certain angle, it's only a certain angle that will give you an exact form. So that's why we did learn about the two different groups of a special angle. So some of those, the first group, they are the angle that lands on the axis. Okay, so I'm getting the x and the y axis here on this corner just to remind you, any angle that lands on the x-axis on here or over there, or any angle that lands on the y-axis up here or down here, the sine and the cosine of that angle will always give you the exact form. Okay? So that's why we're not going to worry about any other angles that is not land on the axis. Okay? And the other group of the special angles, they are the 45, the pi over 4, or the 30 degrees, pi over 6, or the 60 degrees, pi over 3. Okay, so those are the only, pretty much those are the only angles that we will be dealing with, okay, when it comes to the graph of the sine and the cosine. So if the angle, the theta, is equal to 0, okay, think about if it's 0, that means the angles will start from here. Okay, and we already know from the previous sections that the sine will represent the y. Okay, and sine only, we can only looking at the vertical length on the graph, and if the angle actually hasn't start from here, it hasn't moved, that means in this point here, there's no vertical length at all for this angle. Okay, and only has a horizontal length, really. Okay, so when y is equal to sine of 0, since there's no vertical length, then sine 0 will give you a 0. Okay, so you can verify that by using your calculator. Okay, and for the 90, the pi over 2. So that means the angle is from here, from the starting, go all the way, it ends on the y-axis. And when the angle that goes from here to there, okay, you get your 90 degrees angle, but because it lands on the y-axis up here, then the sine of a 90 or sine of a pi over 2 will give you the length of 1. Okay, and again, if this continues to move, if the angle is a pi, which is a 180, so that means this angle continue moving, and it lands on over here, on the other side of the x-axis. Okay, so in that case, the sine, again, it only has the horizontal length. If the angle is down here, then it's no vertical, so this one will be a 0 again. Okay, so anything that lands on the x-axis for sine is going to be equal to 0. And then the 3 pi over 2. So when the angles go all the way to 270, 3 pi over 2, then this, now the sine of a 3 pi over 2 will give you a -1 because it lands on below the x-axis. Above the x-axis, the 90 will give you a 1, but below the x-axis will give you a -1. And again, if the theta is equal to 2 pi, 360, that means the angle will go back to where the 0 is. Okay, so again, any points, any angle that lands on the x-axis will give you the 0 for sine. Okay, so this is going to be the ratio of all of those angles given by the sine. Okay, now if you look at the cosine, and for the cosine of the 0, so that means again let me just get a different color here. For 0 degree, and for the cosine here, anything that along the x-axis, on that side, the cos of a 0 will give you a 1. Okay? And 90 degree, pi over 2. So if this angles go and lands on the y-axis here, and because on the y-axis there's only a vertical length but no horizontal length, so a cos of a pi over 2 will give you a 0. Okay, so similar idea. Any angle that lands on the y-axis for cosine is going to be 0. So if I continue moving on the next one, the pi, the 180. So a cosine of a 180 will land on the x-axis, and so because it's on the other side of the y, so this will give you a -1. And then if you continue going down for 270, 3 pi over 2, and so this one will be a 0, because any point, any angle that lands on the y-axis for cosine, you will get a 0. Okay, and then of course, lastly, if this angle for a 2 pi, 360 degree, going back to where the 0 is, and you're going to get a 1. Same thing as up here. Okay, so once we know how to get that, and on the graph, I'm going to show you quickly on the graph, based on what I have for each of the key points here, 0, 90, pi, 3 pi over 2, 2 pi, okay? I'm going to plot those key points over here for the sine. So for the sine, I have a 0, 0. Pi over 2, I have a 1. Pi, I'm coming back to 0. 3 pi over 2, I'm down to the -1. And 2 pi, I'm back here. Okay? So the graph of the sine, if you join them with a smooth curve, okay? With a smooth curve. And this is one complete cycle of the sine theta. Okay? So the starting points for the sine, really, okay, for the first cycle, it's right now we know that this is coming from 0 and 0, okay, from the point of origin. Okay, I'm going to explain a little bit later about like what the other name for that. But basically, right now, I'm showing you the parents function of the sine based on the those 4 key points, okay? Starting from 0, you got the key points of a 90, 180, 270, and 360, okay? Of course, in your mind, you know that in the radian equivalent will be a pi over 2, pi, 3 pi over 2, and 2 pi, okay? Over there, for the cosine, okay, for each of the key points, when it's a 0, I have a 1. Sorry, just I have a 1 over here, and a pi over 2, I have a 0, and a pi, I have a -1, so it's down here. 3 pi over 2, I'm back to the 0, and finally 2 pi, I'm back to the 1. Okay, so if I need to connect this, I'm going to do this with a smooth curve. Okay, going to smooth it in. Okay, and you will see this is a smooth curve. Okay, sorry, I need to erase this a little bit. Okay, so you get to see it. This is your cosine. Okay, and the starting point for the cosine is at 1, sorry, is at 0, and then in 1. Okay, so this will be the curve or the parents functions of the cosine. Okay, now it's very important that when we look at each of these parents functions, we need to know about some of the special properties that I hope all of you still remember, that we talk about amplitude, the maximum value, the minimum value, the periods of the functions, key points every quarter. Basically, key points happen every quarter. Okay, every quarter of the period. Okay, and then the equation of axis, and then we have a domain, and then we have the range. Okay, so all of this, they are very, very important. So if you look at the sine graph, okay, the amplitude basically is the vertical length. Is the vertical length that is between the maximum to the middle. Or you can say that is the vertical length from the minimum to the middle as well. Okay, so this, okay, or you can say this is the half vertical length between the max and the min. Okay, and the amplitude for the parents functions, the amplitude for the parents functions basically is just the 1 units here. Okay, so it's a 1, and this is going to be the same for the cosine as well. The amplitude is 1. Okay, because if you look at the maximum to the middle, or from the middle to the minimum, this is also 1 units here. Okay, and the maximum values for the sine is going to be 1. Okay, and the maximum values for the cosine is also 1. Okay, we're looking at where the maximum of the graph is happening. They all happens at 1. And the minimum values, they both have the same as well. The minimum is going to be a -1 and a -1. Okay, now beside the maximum, the minimum, I have this little formulas here. And this is a very useful formulas to calculate the maximum values and the minimum values later on when the parents functions start to move around on the Cartesian plane, okay, with transformations. So the formula for the maximum is always taking the absolute values of the amplitude plus the c, okay? To get the minimum is a minus the amplitude of the minus the absolute values of the amplitude plus the c, okay? And the a really is the amplitude. So amplitude here, you can also remind yourself that the amplitude is always the absolute values of the a, okay? So because we're talking about the length, so the vertical length cannot be a negative number, okay? So that's why we put in the absolute value size for the amplitude. And when it comes to the period for the parents functions means where it starts and where it ends. Like what is the horizontal length of from the starting point to the ending point. And one complete cycles of the sine will have the period of 2 pi. And that is the same thing for the cosine as well, because if you see where it starts, the cosine, and where it ends, the cosine, the horizontal length of that is also 2 pi. Okay? So from here to here. So this is the period. One period. Okay? And key points every quarter. Okay? So because the 2 pi is the one period, when you divide this 2 pi with 4, because every period will have 4 equal parts, and then you should know when you reduce that, you're getting a pi over 2, which is true if you look at the graph. Every pi over 2, you get a key point. So some of those key points, they're either the maximum, they're the middle, or the minimum. Okay? So key points, this is the one of the things that everybody has to keep in mind, that how often or when is the next key points happening. So it's every quarter of it, so it's every pi over 2 for the parents. So same thing for the cosine as well. Every pi over 2, every pi over 2, pi over 2, pi over 2, you will get a key points, okay, on the graph. And the next thing is the equations of axis. Well, the equation of axis really is the middle line, okay? So it's the middle between the max and the min. So if you look at the max over here for the sine, and this is the min, okay, the middle, this line here, this horizontal line, will give you the equation of axis, and this middle line will have the equations of y equal to 0. Okay, because equations of an axis means this is an equations, right? So has to be, a horizontal line has to start with the y equal to 0. And of course, once this parent's function start to move elsewhere, then the middle line will have some other values. Okay, but for the parent's functions, for both sine and cosine, okay, the middle line from the max to the min, the middle will be this line here. And this will be your equation of axis. Okay, so it will be the same for both. And domain. Well, domain for the sine and cosine, basically they are all XER because they are the continuous functions. Okay, this is assumed to be continuous on here or over there. Okay, and on and on. So I put an arrow on both sides. So same thing with the cosine as well. We are assuming that the graph is keep on going for another cycle. Okay, or over here for coming from another cycle. Okay, so that's why the domain is always XER. But for the range, because it's only bounds from 1 to -1 and then go on and on and on, and so the y will be always in between. Is greater or equal to -1, but it will be less than equal to +1. It will be the same for the cosine as well. Okay, greater or equal to -1, but less than or equal to +1. Okay, and lastly, I want you guys to look at this formula for the transformations. Okay, with transformations, any functions with the sine or cosine, okay, it could be sine or could be cosine underneath here. And with transformation, then you always get to see a coefficient in front of the sine or cosine, and that A will represent the amplitude, which is the absolute values of the A. And the K inside the brackets here, after the sine or cosine, that K values can help us to determine the period which is equal to 2 pi over K. Okay, whatever the values that you see here, you take 2 pi, 360, divided by that K values, and then you can determine the period. The period is the horizontal length, okay, of one cycle. And vice versa, if you want to find the K, if you know the periods of the functions, all you have to do is take 2 pi and divide it by that periods in order to get the K values to go back here into the equations. And K always has to be factored out from inside brackets x minus the D, okay? And the D values represent the phase shift, how much horizontally the graph is going to shift to the left or to the right, okay? So it's very important that you indicate, or when you describe the transformation, you must including the directions of movement, which is the left or the right, okay? And finally, when the enclose the bracket plus the C, and that C is what we call the vertical displacement. And to describe the vertical displacement, you always have to include the wording of whether this is moving up or this is moving down. And also, I want to tell everybody that that value C will also tell us the equation of the axis, which is the middle line. And the equation of the axis is always y equal to C value here. Okay, so this is a very important piece of information that you guys keep in mind. So in general, the starting point for the sine functions, because it starts from the middle, and the middle actually is the equation of the axis, right? And so, and when you move, actually it affects the phase shift, which the D value here. Okay, so in general, I want you to keep in mind that the starting point for any trig function that has transformations on it, the starting point for the sine function, it's always the phase shift, which is the D value here, okay, comma. And if you look at here, sorry, and depends on how much that move up and down. So the up and down has to do with the C. So when you don't have a C, then that means this is a 0. And that's why in the parents functions, when there's no C value, and that's why you're getting a 0, 0 here, because you don't have a D either. Okay, that's why. But basically, this is the D comma C is always your starting point for sine. Okay. And if you look at the cosine, the starting point, and because it starts from the maximum, it doesn't start at the middle, okay? When you have a transformations left and right, it actually will change the starting point as well. And so the x coordinate of the starting point is always being affected by the phase shift. So it depends on where the phase shift is, okay, D. And then, but the y coordinate is always the maximum. Okay? So it's always the maximum values for cosine. And because the maximum here is a 1, so that's why the parents function, you have a 0, 1 there. Okay?